Hello everyone, I hope everyone is doing good, and in today's video we are going to talk about LangGraph. It's like I have mentioned in multiple of my LinkedIn posts and in my previous video also, like for if you're a data engineer, you want to become a AI or want to bring AI into your workflow in the AI data engineering workflow, then you have to learn some of the framework. You have to learn at least one of the good framework in which you can create a GenAI pipeline. So LangGraph is one of that framework, one of the open source framework. We can create multi-agent workflow. It's a graph based, it's a stateful, so we'll understand what's the meaning of graph, what's the meaning of state, and how this practically works. So in today's video, we are not going to talk about any of the AI agent. We are not going to build any AI agent or going into any LLM model. So this video is mainly focused on the basics of LangGraph. We'll look into it practicals and we'll understand that how we can create the graph. We'll write some programs and we'll understand the LangGraph concept. So this video is fully focused on the LangGraph. And in the next video, I'll come up with integrating the AI agent with the LangGraph. So let's start now. And if you've not subscribed to my channel, please subscribe to our channel and do share this video to your colleague, your friends who want to get into the data engineering field or who want to enable AI into their data engineering skill. So let's start now. So what is LangGraph? So LangGraph is a framework which is built on the Lang chain and which helps you to create a stateful multi-step AI flow using the graph instead of the linear chain. So what's the meaning of the linear chain? So this, what you are seeing here, input chain, output, this is the way how Lang chain works. So there is a linear chain. There is no decision making kind of, or there is no graph or workflow in this full chain. So it's one input to other output. But in the Lang graph, you have a graph. So this is from one of the practicals we'll see here. It's a graph base. So we are starting some process. We are creating one decision making things. If you have to have a decision router, and then you can just go to the different process. And it's also stateful. Means like if you have worked on any class oriented languages like Java or something, in there you create an object of the class and that object has all the meaning of that particular instance. So similarly in the Lang graph we have it's very similar to that. So I've given you the example of this object oriented programming. So in the Lang graph also you have the state which gives the information at that particular flow. So you can have multiple state which can be flowing into your graph, and each state will be preserved till the time your process is getting executed. We'll see that how is the output of state and how we create the state. So in a simple language, we can say that LangGraph is a linear pipeline, is step one, step two, step three. And in LangGraph and LangChain, in the LangGraph, we have a graph-based workflow. So you can create a loop, you can create a conditions, you can create the memory, you can create the branching into it. So this is what is the difference, and this is what it makes LangGraph a very good framework for creating a GenAI pipeline. So before going into the programming of the LangGraph, we should understand that there are few components, and these all components combine together to create a graph, a meaningful graph. So the first thing is a node. So if you see, like, this is router node, this is start is also one of the node, add, subtract, these are the node. Node means there is some process being done in that particular area, so that we call it as a node. So if you're doing some LLM calls, for example, from this add, if there is no add and I'm doing some LLM call from this, so this node becomes the LLM call node. Okay, you can give any name for this. So then there are edges. Edges means which is connecting two nodes. For example, this add process or add node is getting connected to the end. So this is the edges. So there are multiple kind of edges. Like for example, this is a conditional edges. Via additional process, subtraction process, depending on the condition. There are conditional edges. There are normal edges. So these are the edges. State means meaning across the pipeline. Like as I have given you the example of the object oriented programming, we have a concept of object and the class. So state is very similar to that. It has all the information. For example, in the router node, if it has all the information and the meaning, so that meaning and that information will be passed to the subsequent node in that particular flow. So the state is very important. If you lose state, then your add node will not understand what is there in the router node. So creating a full context in a workflow, the state is very important, and we will work more on the state to conserve the state, to pass the state, and this will be also helpful in debugging many of your GenAI pipeline issues. There are two more important things: start and end. Start is the start of each of any lang graph. So you see that we are actually starting from the router node, but we have to connect to the start node. Similarly, if we are ending, we have to connect to the end node. So there are multiple ways, like in conditional ways also you can give the end node. We'll see all that example. So just keep in mind, these are the important things that I thought of covering in this course. Now we'll move on creating the graph. We'll just create a simple graph, and then we'll move on like how we can create a conditional graph. So as I mentioned, like this video, we are not going to touch any of the AIs and LLM. We are going to only look into the graph process, how we create a graph. Okay, we'll move to the practical things. So before going into the graph, creating of the graph, I want to discuss about one of the feature of Python, which was introduced in Python 3.8, the type dict. So before this 3.8, in Python, you cannot directly enforce the data type in when you create a variable in the dictionary, especially. I'm talking about the dictionary. So it is type dictionary. So how we used to write before, like we used to give name and the just name, age, anything. We are not mentioning the data type. We are not enforcing the schema. But with the type dict, you can create the class. You can give the name, like name as a string, age as int, and then when you give the input, if you give age as a what do you call a string, then it will give an error. So there will be a type check now. So this has been introduced here, and this is very important in creating the pipeline. There are multiple advantages for that. So you are enforcing a schema. So that means your schema remains intact. Your data type remains intact from starting to end. In the dictionary side, we have a schema in the dictionary, so we are talking about enforcing schema. It's a better readability when there is a big pipeline when you create, for example, data engineering pipeline. So it will be when you start reading the program, you will understand that which schema or which kind of data type you are going to deal with it. It is also helpful when you write in the ID, like there will be suggestion depending on the kind of schema you have described while creating the variable. So on the screen, what you are seeing right now is one of the simple graph, LangGraph graph. You can see here below when the output is a graph, and we'll understand what the how we have to create this graph. So I have done in the VS Code. You can directly create a virtual environment in the VS Code, and then obviously you will have the Python and other stuff. Try to get LangGraph. Just install LangGraph by the pip install. You will get the all this library. So we only need one is the dictionary side because you will be using the Python type dictionary, and then just install LangGraph. Okay. So first we have to create the node. You can give any name. We are creating the node, a class in which we'll define the structure, the schema of your state. State means the information, like the input and the structure what you are going to give into the LangGraph. Now I want only name to be there. Like I want only name to be input. We will pass only the name. So name become one of the important parameter in the state for keeping the state. So I'm creating a class of it. Okay. The type of this class is typed it, and the name is a string. So if you write like this, if you don't give anything, it will suggest like this is a string. So this is good when you are using type dictionary. So your ID also becomes very intelligent to give you that suggestion. Now we have to create a function in which this class type will be the state will be this input, and the output will be also state. So we are returning state. So in the state, what I want in the state, I want only one parameter, that is name, because we have defined only name here. So you can define 4 5 parameter in this class, and then you can use only few in the state. That is also possible. But I'm not going to complicate the scenario. I'm just keeping the name as one of the component, one of the parameter for this class, and this is being used in the state. So now this name becomes the state for one flow. For the another flow, we can give the another name, and that will become the state for the another flow. Okay, so just understand, like we have to create this class, then we have to create this state by creating this kind of function where your the class type which we have the created here, that becomes the state as an input, and that also becomes the output. So state name equal to state name, what will give the name, that will get into the state value, and that state value we are going to return. Now this was about this Python. Now coming to the graph. So we are defining one variable graph equal to state graph and agent node. So state graph is one of the libraries in the lang graph, and that is used to create the graph. So you have to use a state graph, and here we are giving the class name. Now we have to start adding the node. You remember, like we have discussed about the what is node, what is edges. So now we have to create the graph by adding the node. So we have to create this kind of graph, start and first node. Fine. Now how to create this? We have to create one node, first node. We have to assign to the start, we have to assign to the end. Simple. So what we are doing, we are doing add node. And what is the first node? First node is the state of this, what we have defined the set node. Okay, so this what we are doing, add node, first node. It's a name of the node. You can give the set node normal name also. So set node becomes one of the node in the graph. So if you're not writing these lines, your graph will be not completed. This is just defining the state. Okay. Now giving that state or putting that state into the graph, we have to add this line. So we are adding first node. So this become your first node. Now this has to get into your start and end. We need start and end also. So we have graph.set entry point, which is the first node, because first node is my entry point and the first node is also my end point. So we are giving set finish point equal to first node. So when we say that set entry point equal is first node, your first node get attached to the start. And similarly, when you give the finish point as a first node, then your first node gets attached to the end. So this is my graph structure I have completed. So once you have completed the graph structure, you need to compile it. So graph.compile, when you will give, it will be compiled. So now this line is for just viewing the graph. If I'll run it again, okay, okay, it will instantly give. So this is your what do you call the graph. Now I have to give the output. So the output will be simple. I'll just give the name, and name will be the output because in my state only name is there. Fine. So we'll write here in one variable app.invoke. App.invoke. I am giving the name. Name is that variable we have defined as hello, and result name. So when you run this, so you will get the name. You can also structure your string like I have written here. Hi, my name is state name. So what you will pass it here, that will get into this and it will create a string. So now this information become the state and we are returning this state. Let's see how it works. We'll run this. Okay, this graph, it got compiled. We'll pass some name. For example, I'm passing my name, Santosh. So it will give, hi, my name is Santosh. So you can format the string. It's not necessary that what you have defined here, the same should go as one-to-one mapping. You can do multiple type of formatting as you do in the Python programming, right? Now we'll see one of the conditional node. We'll create one conditional graph. So before going into the conditional graph, we'll discuss one more thing. We'll discuss some of the transformation. Like in the previous graph, you have seen that it was just we were just passing the name, we are getting the name. Now we want to do the summation. Like we have given the list of a set of numbers, and that number should get some of the transformation and get you the output. So your state will get the input as a set of number, and your state information will become the aggregation of that number, and that aggregation of that number will be passed into different nodes, and you will get the output. So your final graph should look like this: start graph, some processing you are doing, and the end graph. Earlier we had start graph, just giving the output as a name or any of the parameter, and the end graph. So how we will do that? Few things are common. The same thing, you have to import these libraries, and then you have to clear the class. You can give any name. So I've given the agent state because it's very getting relevant to the information what we are doing. So we create a class of the type dictionary, where we have the product ID, we have the name, we have the address, we have the result. So product ID, you see I have given the list of the product ID because we will give the input as a list of the product. So that list of product will get summation. So product ID is the list of integer type, name, address, and result. These are the string type. We define one process. So this is a function, and you can consider it as a node in a graph in the LangGraph, because this becomes the node eventually. So you can create multiple if you want multiple node, you can create multiple function, and then when you add in the graph, then you can see multiple node. We'll see in the next example. For now, we created this function, the agent state. This class type is the input, and that this the same is the output. So we are returning the state. In the result, I have taken one variable result. So if you are creating a state result, and if you are if you're storing some values, doing some manipulation, some transformation, and storing that values in any variable. So first you have to define that variable in this class. Obviously, how we do in a object-oriented programming. So state, result, and what I'm doing, summation of the state product ID. So this values I'm doing the summation. Why I'm writing the state? Because for this state I'm passing these many numbers. When we are running from another instance, so there can be a different state. So for this state, get these numbers as an input and intact in a state information. So whenever we define the node, we always ensure that now it's not a variable, it becomes the state information, like how we do in object oriented. That variable becomes the part of an object, so that object contains all the values of that variable. Similarly, here the state contains all the value of this variable, which is result. So now result contains the summation of product ID. Now you see we are returning the state. Fine. Now, if this process is completed, then our next step is to create the graph. So what we are saying, we have to import the libraries, we have to create the class, and then we have to create the node. If you have a one node, create a one function for that. If you have a, see, this is not actually a function. For making you understand, I'm just telling the name as a function. This is the state thing, stateful. But consider it as a function for your understanding. You can create multiple functions, that will be a multiple node, and then you have to create the graph. So what we want, start, process data, end. One more thing, whenever you are going to create a GenAI pipeline with the LangGraph, the graph vision of this graph should be already created. You have to create the blueprint of the graph. Like before writing the program, you should understand that which kind of graph you are expecting out of this program. So I'm expecting this graph. So that means I have to create this node, and I have to attach this node to the start point and end point. So I'm adding the node as the process product. I've given the same name here. Entry point is the same node, and the finish point is the same node. I've compiled it, and you will get this output. Okay. Now how to invoke, like how we have done the earlier in the earlier part, app.invoke. So we are doing the app.invoke. We are giving the product ID, we are giving the name, we are giving the address, and print. I want to print the only answer, so it will give answer result, because answer contains everything. Your sum is 6. Why? Because I have given the result value as your sum is 6. So now what I have done is I have added name and address also information in the state. Earlier there was only a result as a part of the state. So I have added address and I have added name. And in the name I have mentioned like, hi, my name is this. Now these, all the address and name also become the part of the state. Okay, I'll run it. I already run it actually once. I'll create a graph. You can see this if it's running. And then we are giving this. I have already run this. So I'll run it again. So you can see this is my input, and the output. You can see the output is name. Hi, my name is Santosh, address, and the result. So these three are the output of my LangGraph. Okay. Now we'll see one conditional LangGraph. We'll create one conditional LangGraph, and then I think we'll be good to start with the next session, which is the creating the agent in the LangGraph. So this is one of the conditional LangGraph which I was talking about. Like I want to get the input from the user. Like you can see, I've already run it. I want to pass, like if you want to do the addition or subtraction, and that your input addition or subtraction will be the deciding factor on which of the path of the graph we have to take. If the user has taken the path as plus sign, means addition, so that will go to the addition node. If you have taken the negative, means subtraction, then that will go into the subtraction side. So now you understand one thing. Before I've started writing the program, or before we are going to write a program in the LangGraph, you have this blueprint in your mind, like this kind of graph you require. Because once you create the graph, this is where we are creating the graph. You have to be very much clear, like what you are going to visualize. Then only you can write all this line. uh, Till this line, these are just the programming logic, but this is where we are creating the graph, and this is important to visualize before you write it down. Okay. Now the similar process will just start this process, import the libraries. We'll also import a start and end. We'll see why we need that. Now we have one deciding variable, that will get the decision from the input, like if you want addition or a subtraction. We have a result, and there are two numbers for the addition and subtraction. Fine. We define two node. Why we define two node now? One is for the addition and one is for the subtraction. So for the addition, we have a simple result equal to number 1, number 2. And in the subtraction, result equal to number 1 minus number 2. It's very simple. We are passing this state. We are creating the two function. It's not actual function, just for understanding purpose. I'm telling this is a function, but actually this is the state information. So in one of the state information, you have all this thing, all this information. So now by this, you can understand that we are going to create the two node now. Okay. Now we have to also create one more node, that is called a router node. Now this node, we have to also decide on this node. So this add and subtraction is a simple node. We are adding and subtracting. In router node, we have to give the intelligence that we have, that process will go to the additional node or the process will go to the subtraction node. So for that, when you create this node, router node logic, you have to define that conditional by if else clause. So how we are doing? We are defining this node. Okay, the same thing here, input as a state and output as a state. So now we create this node, process decision node. The same way we are getting input as a state and output as a state, and the condition is if process decide, the variable will pass one variable. If the process decide is plus, okay, this which you have defined here, the process decide, this variable. So if the value of this variable when you pass is plus, then return the text additional process. If it is minus, return the text as a subtraction process. If it is the different kind of number, you can give the raise an error, invalid process decision. Okay, now we have to create the graph. Important thing, we define the graph variable now with the state graph, and now we have to add the node. The first node we are adding is simple, add node, subtract node. Add and subtract is just the text of that node. Add addition node and subtraction node, which is coming from here. Fine. Then add node is a router node for the decision making. You can give any name. I have given the router node. Router node, we are defining lambda x equal to x, means what we are passing in this function, and that should be the output of this router node. Why we are doing this, I'll make you understand after a few lines. First, we'll add one edge. Edge means start to router node. We have to create one edge. Add edge. We are getting the add edge and start. What is that? Router node. So router node become one of the edge, and this is from this also. From router to add also we are giving creating one edge. So we are also going to create one conditional edge, as I have mentioned that there are multiple type of edges. One is conditional edge. So the edge what you are going to create from router to add or router to subtract will be based on some condition, right? Like plus and minus condition. So what we are doing? Condition edge. The edge name is router node, which we have defined here. So here we have mentioned lambda. Like if you understand the lambda in the Python, like we pass a function, a variable, and that will get an output. Here we are not doing any processing in the lambda, but you can do multiple processing. Here we have used lambda. State is an input, state as an output. So conditional edge, router node, process decision node. Okay, so this node will become process decision node, and it will be have a condition. If the additional process is there, then it will go to add node. What is my add node? Additional node. And from where I'm getting additional process, this is where it is getting returned. Okay. Subtraction process, if your subtraction process is there, like if we get a return as a subtraction from process from this process decision node, you see I have mentioned here process decision node. Depending on this value of this process, how we do in the switch, if you have used switch in any of the programming language. So consider this as a switch. We are getting an input, and depending on the input, we are going into this two node, add node or subtract node. If you want to understand what is this, you can understand just for the understanding purpose. We are just calling these two function. Actually, this is not a function, but we are calling these two function. In this case, this is as a node. Now we have to add this add to the end and subtract to the end. So add one more edge, add to end, another edge is subtract to end. See, there are multiple ways you can write the programming in the LangGraph. So this is one of the simple way. I'm just trying to put it here. So what we have done, we'll see again. We have imported the libraries, we defined all the variables, and then we have defined two node add and subtract. We have also defined one decision node, which will return based on the input. Plus means additional process, minus means subtraction process, one for the error handling. And then we define the graph with the state graph, means that graph will contain that particular state. We added a node, add node, subtraction node. We have added one router node based on the condition, so we have to define this lambda. We add one edge node. Edge node is from the decision making node, router node to the start node. There will be two more edges will be there for the add to end and subtract to end. Earlier we were not having the decisional thing, so we were having a single node here and that was getting connected to the end. But now we have add and subtract both, so we have created an add node, added an add node, add edge and add edge. Okay, now we created this graph, we compile this graph. Okay, I have not run this one. So you can directly do in the PyCharm, or directly if you don't want to use the notepad, notebook. Because I use the notebook because for this display purpose, I was not getting it in the PyCharm. So you can see the graph here. Okay. Now I'm giving the input number one, number two, process minus result equal to zero. What is this result equal to zero? I have defined here result which will capture the result, this result. So by default, the value will be zero or null. In this case, result is integer, so it will have the by default value of integer. But you can keep it as a zero or you can remove also. It doesn't matter. But it's good to define from your side. So I've given result equal to zero. Read app print app invoke input. So when you run this, you will get number one is this, number two is this, and the result equal to minus 40. Process decide is minus. Okay. So what we have done, we have given the process decide as minus. With this process decide as a minus, it will go into the subtraction process and it will give the subtraction. If I add here as plus, let's see, and run it. So it will process decide was add, and this is the add. So it looks simple. So now you will have one question like, we can do all this stuff in a normal Python programming language or any of the language. So why we are creating graph in this case? So this LangGraph is not meant for a normal programming thing. It is meant for creating a GenAI pipeline invoking multiple agents. So if you create one agent in each node, so each agent will do separately or parallelly and separately a different kind of task. And depending on some condition or without any condition, they will combine together to give you a single output, or they can give you multiple output. So now we are seeing the node as a single process, but actually when you will create the agentic solution with the help of LangGraph, then your each node will become the agent. So now you understand, like you create a 10 node, so that 10 node becomes your 10 agent working for a one state. And to have the single point of communication or single point of truth between each of the node, we have to include state. That state brings a truth, a single point of truth to each of the node. So slowly you will understand like why we are getting into the LangGraph. But this is beautiful. Like if you practice LangGraph, you will love this. This is very simple. And see, you can do all this stuff without using any LangGraph, LangChain, any of the framework. But for that, then again, you have to create the state. You have to writing multiple logics. So if you are going to create a normal chatbot in the LangGraph, you can have the human message, you can have the AI message. If you're not using any framework, then you have to write a different logic for each thing. I hope you will get some kind of information, some kind of valuable information from this video. If you have any doubt, please post your comment. You can contact me through LinkedIn or directly mail me. In the next video, I'll see you with the agentic solution or creating some of the simple agent with the LangGraph. We'll start this process in a simple process. This is the part one. I'll try to deliver something which will be very useful to implement in your project or in your company or organization. Okay, we'll meet in the next video. Till then, be happy and happy learning. Do subscribe to my channel. Thank you.